Greetings, class. This segment is hopefully will successfully build on the segments that you have already watched regarding hypothesis generation and hypothesis interpretation. Now we're going to begin discussing a specific procedure that we will use to test hypotheses. Specifically, we will be testing the null hypothesis H sub 0. And the procedure that we're going to use is known or is referred to as t-tests for one sample. T-tests for one sample. And once again, although I mentioned this in a previous segment, what that means is that we are going to take information from one sample and compare it to an assumed parameter. That's why all the hypotheses that we've reviewed up to this point dealt with an assumed parameter. In fact, the assumed parameter, the assumed population mean, was actually mentioned or referred to in the hypothesis itself. So hopefully that is clear up to this point. Hopefully you have a good understanding that a t-test for one sample is going to involve calculating a sample mean, okay, a sample, a subgroup of the population, and then comparing that mean to an assumed parameter. Now, here's why we have to do t-tests. Well, we have to conduct hypothesis testing using t-tests for a couple of reasons. One is one that we've already referred to explicitly, and that is that whenever we sample, we have error. And so it shouldn't surprise us that any time we have a sample and we wish to compare that sample, or more specifically, anytime we have a statistic that came from a sample, like the mean, and we wish to compare that statistic to an assumed population parameter, it should come, hopefully at this point in the semester, it should come as no surprise that there will be a difference between that statistic and the assumed parameter. There's bound to be a difference because of sampling error. So we need t-tests in order to use the appropriate probability distribution, in this case the t probability distribution. We need t-tests in order to use the probability distribution so we can determine whether or not the difference that we do observe can be attributed to chance, accident, sampling error alone, or if something else besides those things, chance, sampling error, accident alone, might be going on. So that's the first reason why we need to use t-tests in order to test hypotheses. The second reason why we need t-tests to test hypotheses is because we need to convert our information, our data, into language that the t probability distribution can understand. What I mean by that is that we are going to be taking actual mathematical differences between a mean and assumed parameter, the actual mathematical difference, and we are going to convert that difference into units of standard error. Again, that's what t-values are. T-values of any type are units of standard error. So that's the second reason why we need to use t-tests, in this case t-tests for one sample, in order to test hypotheses, because we have to take think of what some of the information that we've referred to when we were talking about hypotheses has dealt with. Average age, right? Facebook users are of a different age than the general population at 58 years old. Or heart rates, right? That's mathematical information. Commercial pilots develop heart problems at a significantly different rate than the general population at 21%. Okay, those two things, average age, years, right? That's information, that's data, statistics. Percentage of heart rates, that's data, that or average percent of heart rates, that's data, right? Well, the t probability distribution, which we need in order to test these hypotheses, or test those hypotheses, The t-probability distribution doesn't speak the language of years. It doesn't speak the language of heart rate. It doesn't speak the language of anything except t-values. So we need to, in order to conduct a t-test, a little bit of foreshadowing here, in order to conduct a t-test, we need to convert our mathematical difference into language that the t-probability distribution understands. And the language that the t-probability distribution understands is the language of t, the language of standard error, specifically units of standard error.